Thanks, Dave. Our next speaker is Steve Waldherr. Steve is the Mission Interface Manager of the Mission Support Definition and Commitment Office of the Deep Space Network at JPL. And the topic of Steve's talk will be Deep Space Network Services for Hire. So if you ever wanted to hire services of Deep Space Network, Steve will tell you what you need to know. Steve?
You gotta get the communications link set up. Okay. If you, great. Okay. I'm Steve Waldherr, as they mentioned, and I'm from the Deep Space Network out of Jet Propulsion Laboratory. And as the rules are set up is we're on the hook to offer validation for navigation and also to receive telemetry if you guys are CCS standard. If you guys are not CCS standard, then you can't really use the DSN. Now, my office is the Commitments and Definitions Office, and in my role in particular, I do all the future missions. I do the Discovery AO. I currently have the Marco CubeSat, the JPL Inspired CubeSats as well. And then I also do Mars Odyssey, Mars Reconnaissance Orbiter, my other customer is Cassini. So I kind of do a little bit of everything. And so they say, hey, why don't you do this CubeSat Centennial in your spare time? So I'm going to give it a shot. Anyway, that's my phone number there and my address. And in the back of the package, I have reference websites that has our DSN service catalog and also some other references that you guys can utilize. Okay, next. Okay, this is just kind of a generic picture. It shows the spacecraft control data handling and then the comm system. What's important to us is the comm system down to the ground as far as the ground network and the Deep Space Network. And then one of the things I did want to mention is I'm actually part of the JPL Interplanetary Network Directory. On the Deep Space Network side, we have antennas and data, and then on the other side, Carol is going to present a little bit after me that talks about the multi-ground systems, support system, and that includes front end and some other services, navigation services and scheduling. They'll talk a little bit more about that. But that's in this box over here on the right. And then whether or not you want to throw science in there, and why not we then distribute the data as appropriate. Okay, next slide, please. Okay, we're optimized really when the DSN came into birth. We're really optimized for Deep Space Network Category B type missions. But we do support a lot of Category A, near Earth, lunar missions, also missions at the L1, L2, Earth leading, Earth trailing positions as well. We have a lot of customers, of course, NASA sponsored missions. We also do other government agencies such as JAXA, the Japanese Space Agency, the European Space Agency, and so we do support those on a routine basis day to day. And then international partners, for example, Cassini has a European collaborative where they put science experiments on board a U.S. spacecraft. We do different types of orbits, geostationary, we do elliptical, of course, lunar, Lagrange, Earth drift away, planetary. Now, the frequencies or the mission phases we support depends on what the customer wants. We do have customers that come up, they handle launch support, and then they don't want us to come online until later down the road. But basically, the services we offer is all pre-launch setup, data flow, ground data systems testing, launch and early orbit phase, in other words, after separation from the launch vehicle, till you get to your destination, and then on-station support. And then in situ means, like, for example, if all of a sudden we're having problems with the spacecraft, NASA spacecraft on the near-Earth network that God is utilizing, and they want the DSN to come up and then support it, kind of like an ad hoc. We also provide that type of service. Well, we have the Sierra band, the X band, and then also on the Ka band. On the Ka band, we support both the 26 gigahertz as well as the 32 gigahertz. The difference there is also in the frequency bands, We actually break the frequency bands up between near Earth, Sierra, X, and KA, and also deep space frequency bands, near Earth and deep space. The Goddard office controls a lot of the near Earth frequencies, and then actually JPL, our spectrum office, controls the deep space frequencies and coordination of that. Okay, next slide, please. Okay, kind of the big picture, of course, we put the 70 meter up there because we're pretty proud about that. But basically, we have 170 meter at each complex and a lot of 34s. The idea, of course, is to get the data from the spacecraft to the antenna, and the way our antenna infrastructure is set up, all the data from our antennas go through the signal processing center at that complex, and then from there to JPL Central. And then from JPL Central is where we distribute the data. Same thing that's on the return link. On the forward link to command your spacecraft, same thing is from the Mission Ops Center, comm through JPL Central to the signal processing center, and then out to the antenna. Okay, next one. Okay, the complexes, we actually have it in Madrid, Canberra, and Spain, kind of equally spaced around the Earth. And as I mentioned, we designed for deep space. This was to account for rotation of the Earth, so we have continuous view of something that's out in deep space. At each complex, we have a variety of antennas, 34 meter beam wave guide. We have 34 meter high efficiency antennas. Those are some of the little bit of the older antennas. And of course, our older 70 meter that actually we have just gone through and refurbished over the last several years. The 70 meter is one of the more expensive maintenance because of the hydrostatic bearing, to lift that weight up on a hydrostatic bearing. So there's a lot of maintenance on that. And eventually, 70 meters is going to go away. We had talked about it in 2018, but now it's been pushed on down the road. We have a development and test facility located at JPL. So this is for compatibility testing, radio frequency compatibility testing. You take your CubeSat on carry-on luggage, fly it down to JPL, and then we take it over to the test facility and then actually do radio frequency testing. And if you're available, we'll actually do an end-to-end data flow as well at the same time on the back end of the compatibility testing. And we also have a compatibility test trailer where we can actually take it to your site, whether it be Denver, the East Coast, or even close to the launch facility, such as Vandenberg. And it has a full suite of equipment that emulates a DSN tracking station. And then also at Mill 71 down at KSC, we also have a facility that we can also do compatibility testing. A lot of customers do it pre-launch at DSN or JPL, and then pre-launch they have us go out and do a condensed set of testing actually at KSC. And that's the trailer there in the center. All right, next please. Okay, this is just an overall picture of where our antennas are. Okay, we have, like I mentioned, 170 meter at each of the complexes. We have then a suite of 34 meters, and then we actually have a couple of new antennas. New antenna just came online in Canberra, and then we have also another antenna coming online in 2016, I believe. But this just kind of gives you an idea. You have the aperture feed DSS numbers there, as you can see. They start off usually in the 10s or 20s for Goldstone, and you'll see a little bit of pattern there with Madrid and Canberra as far as the number scheme. Okay, next. I didn't put the G over T on there, I probably should have, but this is a list of all our antennas with the frequency capabilities, and we show the different frequency band, both for uplink as well as downlink. I think you had a question about deep space. This is a slide that shows the deep space KA band capability. And then for the KA band downlink, we have the 8400 to 8500 KA band on each of the 70 meters. Okay, next slide. Okay, we have a DSN service catalog, 820-100. And part of the service catalog is not only tracking the spacecraft, but we also include system engineering, advanced mission planning, so as far as we advise as far as how to plan for the mission, schedule for the mission, and how to set up some of the support with the use of the DSN. We also do the radio frequency compatibility. I do mention that these services are actually included in the aperture fee. And spectrum and frequency management, a lot of the customers will do their own frequency coordination, but we offer consultation services in the spectrum realm as well. Spacecraft service, say for example, after you separate from the EM1 and we don't see the spacecraft, we have the capability where we actually take the aperture and do a search, both in physical pointing as well as also frequency search. And that's what I talk about here, is spacecraft search capability. We have that set up usually during the launch and initial acquisition, which is the first round contract after separation and when the spacecraft comes on. For the data services, we have the standard, which is the cheaper way to go, which is included in your standard aperture fee. And of course, if you want the Cadillac, you can also pay for the Cadillac. Okay, next slide. The way our services are set up is basically kind of pick and choose, plug and play. The idea from standard services is that we push away from standard, or should I say specific equipment for each type of mission. So the idea is to keep the costs down. We are able to support a broad band of customers utilizing these standard services. And one thing is there's no development, there's no real adaptation. It's really kept down to the minimum by using the standard services. And part of my job as a mission interface manager is to take the customers and kind of align them with the standard services and then discuss options as far as the costing. And then the provided data services, you have all the standards, the CCSTS, and all these references here. I really won't go into them. But it basically, what you learn on this, and if you are the standard and if you are CCSTS, it's more versatile because you can go on to bigger and better things as well, or actually go international with international partners as well. Okay, next slide. Now, when you purchase services on the Deep Space Network and the aperture fee, okay, all that is included. We include any type of command service, telemetry service, refrain, packet service, telemetry relay service. For example, Marco, which is a JPL mission, is going to relay data from InSight, the Mars lander, and relay it directly back to Earth from the CubeSat. So we actually offer relay service as well. But in your case, I haven't heard any interest in anything like that yet. But it is a service we do offer. Beacon tone, that is where basically, depending upon the spacecraft sends a tone. Say you go into hibernation for 2 to 3 months, and then you just want to do a contact, keep costs down, we do a short contact, and from the tone from the spacecraft, we can tell that everything's healthy, rather than a full-blown support with engineering data and whatnot. Tracking services also are included in the NCP, which includes two-way Doppler, as well as ranging capability, where you take an encoded signal of range data, transmit it up to the spacecraft, transponder turns it around, and then we can actually calculate range, tie it in together with the Doppler. And that's all part of also the validation and tracking values we talked about. Now, I show this up here because I kind of want to say these are some of the other things we do for our antenna, and also compete with time on the antenna network. Radio science services, radio astronomy. We actually do radar service where we actually get radar off of Mercury, Venus, and nearby asteroids as well. Part of the service management is also included in the aperture fee, so that's included, kind of a package deal. Next slide. Okay, well, we encourage use of standard services, like I mentioned. If you need something else, we can do unique services and tailored services, and then there is an additional charge. Okay, let's go ahead and go to the next slide. Okay, the user community of the tracking assets, the hours are limited by practical limits. Okay? In other words, if you have a customer come in and says, I want 24/7 for 60 days, that's kind of unreasonable. We have a lot of customers, there's a lot of competition to get the time on network. In fact, one of the things we do is we do a right ascension chart of all the spacecraft. And when all the spacecraft are in the same part of the sky, there's a lot of competition. And if your spacecraft happened to be the other part of the sky, you have a lot better capability of getting the time on the network. I'll show the scheduling in a little bit, but late changes to the schedule are really disruptive with the DSN. We're approximately 15 to 18 weeks out conflict-free in the schedule right now. So on the CubeSat world, what that means is the better planning, the more advanced input, if you decide to use our services, is the better off we are as far as being able to get you the time. In addition to supporting the tracking of spacecraft, like I mentioned, radio astronomy, radio science, the radar communities, and then one thing I didn't mention is maintenance of the antennas. Okay, it also has to compete with all the other customers. All right, next slide. Okay, this is just to give you a little bit of an idea of the scheduling. We start 5 to 6 months out. We take a generic input of what the requirements of the customer are, and then we put together like a skeleton schedule. And then at 2 to 3 months out, we work the conflicts out, and then we actually have folks that go in and that augment the software that has the different gives and takes of each of the spacecraft requirements, the view period, and then works a conflict-free schedule. Now, what happens is what I did want to mention is down here, when launch slips, all heck breaks loose. Because you have to put in contingency schedules, and then now all of a sudden, all the other customers, say for example, Cassini, we're sequenced on the spacecraft about 12 weeks out. Now all of a sudden the schedule changes because launch changes, and now they don't have that track. They have to go in and resequence the spacecraft. Same thing for one of the Mars orbiters. They're set up to do the relay data for one of the rovers. Now all of a sudden that's disruptive because now they've got to reset up on when they can get that relay data from the rover to the orbiter and then down to the DSN. So I don't want to go too much into this, but I just say scheduling is an integral part of use of the DSN. And part of that is actually a scheduling representative that represents the customer. And then also the MGSS, which Carol's going to talk about later on, is going to offer that service. Or, like say, the customer can also do their own scheduling as well. Next slide. Okay, I want to show a little bit about a document tree. This is the key document here, DSN Service Catalog of our standard services. This document here, the A10-5, that has your GOT, that has your bit error rate, that has all the performances of the antennas, 70 meter, 34 meter, HEF. It also has a horizon masking, and basically it's an online thing where you go through the tabs, and on the back of my presentation is a link from my commitments website that has access to the document. And then over here is the software interfaces. For example, a lot of the standard CCSDS interface that we're kind of marketing is a space link extension, both for the forward link command link transfer units and return link between for the telemetry. A lot of our daughter missions use this APL, and actually this is how we interface with JAXA and ESA as far as the exchange of telemetry and command data. Now, part of my job here is once I get a customer in here, on the Goddard side, they do a project service agreement for the Near Earth Network. On the DSN side, we do a DSN service agreement. This says what services out of the service catalog that you're going to utilize. It has an aperture fee cost sheet in there. It has a loading profile of the customer. And it also has specifically the length of mission, the mission phases, and details. Now, this document then flows down into what we call operational interface control document. Once you subscribe to these services, how do we get you the data? What's the interface? Okay, what's the time tag requirement on the telemetry? What type of tracking data as far as the media that we're going to give you, the tracking data, we'll give it straight to the customer. And this flows down, and so I do this document as well as this document, and I work closely with the customer in generating both these documents. This also flow down is into the compatibility test plan. This is actually a document we work with the customer and the compatibility test team, the engineers, on what we test on the spacecraft, whether you have telemetry and ranging simultaneously, does the command interfere on the transponder on return link with the telemetry on the subcarrier. We also do a lot of spectrum plots. So the customer actually has how compatible we were with that spacecraft and the actual report. So they actually get a copy of this, and they are a signatory on this. Now that flows down into, okay, once I get to the station needs a document on how to configure their default tables, what the data rates, and this flows down into what we call the DSN network operations plan, as far as how we actually support it from the station side, from the operations side. Okay, next slide. Okay, as I mentioned, I'm the mission interface manager. My particular office does the future missions. And we work with the standard services. We do the costing. We also define custom services, for example, if you require any. And work with you as far as what the costing of this, the implementation of this, and the schedule. And then the final mission operations design review, or equivalent, I support that, and also can provide input from the DSN's perspective if you are, okay, there's no showstoppers, it looks like they're all standard services, so I can then help as far as providing input to that review as far as, yes, we worked with the DSN, and it looks like we should be able to provide services. Now, useful information on the documents from the project side that I utilize is, okay, mission plan, navigation plan, and how you guys operate the spacecraft. Because I take that and then work with you as far as to make sure that we're aligned with how we operate on our side to work in concert together for mission success. And then also as far as the DSN doesn't do link budget. It is actually the customer's responsibility to close the link to provide, and they generate the link budget. And there's a couple vendors out there that they can actually go to subcontract it, or they can do it themselves. But the DSN, we don't validate that link budget, but I do help as far as if there's any questions on ground parameters, the G over T, that kind of information, what the losses are in our receivers and that kind of stuff. As far as our station parameters, that I can feed back to that customer when they're generating the link budget. And then, so these are the preliminary for mission critical design review. That's one. There's also a lot of times we have for missions, and like I say, CubeSat's kind of a strange thing. It's a lot different than normal type missions. You got different names for reviews. It's not like a normal phase E, A through E, the operations. So I just say operational readiness review. So like the final review before we launch, okay, operationally, how we're going to operate from the DSN side as well as from the project side, and I'll support that from the project for their review. Okay, next slide. Like I say, this is just an example. And the main point I want to bring up with this slide is that lead time. With our mission, sometimes it's 2 years out, 3 years out, that you go through a lot of these major reviews. Now, CubeSats, okay, part of keeping the costs down is there's a lot less review, a lot less oversight, and then more actually getting the job done. So it's a condensed version now. That puts us in a little bit of a pickle because we have less time to prepare, less time to set up, less time to get ready for the ground data systems testing and validate our ground network to support that customer. So from a CubeSat review, we really want to get in early as possible as you guys develop towards the actual design and operational review as far as what you guys are going to operate. The sooner we get involved, the better it is for us to help us out. Okay, next slide. Now, part of the pre-launch RF compatibility, like I mentioned, I got 5 minutes left. I kind of talked a little bit about this. A lot of missions are about 1 year out from launch, but some of the CubeSats, you might have to do it 9 months. The whole idea is to do the RF compatibility. We do offer, say you have an engineering model of a radio, okay? You don't have all the telemetry stuff tied into it, but you want to get a warm fuzzy that the engineering model is compatible with the DSN. That's included in the aperture fee at no cost, and we'll actually do that at the JPL facility. And then when you have the flight model ready, several months later, you can bring that to JPL and we'll do another test on it. So we do offer that. But the sooner the better. The idea is if you got problems with it, we want to find out before you separate from the launch vehicle. So, okay. additional validation info. Inside, we have DSM mission service and everything. We also have what we call a MSIPP document reference, and that's just kind of general information as far as how we operate on VoiceNet, how we deliver pointing information, scheduling, and that kind of thing. That's generic to all missions, and that's also some good backup. Next slide. On the DSN costs, as I mentioned, in the Aperture service, we provide the command, telemetry, and tracking services included. So when you rent the Aperture, it's everything. You don't get charged extra if you want command or if you want range. You get everything with that Aperture. Okay, next. Additional fees for development of unique services that are currently non-standard. And then, in addition, there's a telemetry, tracking, and command. It's a very small fee as far as the engineers to help set up for that customer during the pre-launch. The operation costs and capabilities, special unique requirements as I mentioned. Say you need a comm line between JPL and Denver or JPL and Moffett Field that isn't part of the NASA comm infrastructure. If you had to lease comm lines to get telemetry to you, there would be additional costs for that comm line. And then on the radio frequency compatibility testing, if you go above and beyond the engineering model in a tested JPL, say you want a second or a third with the flight log, there would be additional costs there. Now, part of what this is important, I actually have to do a cost plan. Once I make an arrangement with the customer for that particular type of service, part of it on my side is I do a task plan. But what's more important here is between the customer, to utilize a NASA asset, you have to do a Space Act agreement. That's a contract between the customer and NASA that you're going to be utilizing one of their resources. We kind of talked a little bit about that. I think, did you mention in the rules?
We did mention the Space Act agreement, but we did mention that there would need to be an agreement.
Yeah, between that customer and NASA directly. Because JPL just can't go out and say, okay, we're going to support that mission. We always need buy-in and approval by NASA headquarters. And then also for the Spectrum Act, you mentioned that we actually, for civilian CubeSats, go through FCC. Okay, next slide. Okay, these are the reference websites I talked about. That's my commitments website. It's set up for the announcement of opportunities. Has my service catalog on there. Has a link to the 810-5 telecom parameters of the stations, my contact information as well. It also has the interfaces for how to get to it. Okay, next slide. Okay, as I mentioned, I am the mission interface manager. We also, part of the Aperture fee, when you pay for it, you get a project data systems engineer that helps to set up and whatnot. It also includes a network project operations engineer that gets the station ready, and also a mission, on the project side, we need an interface, usually a mission manager, whatever you decide to call them, and then a scheduling interface, whether you contract that out or you do that yourself. Okay? And then here's my contact information. So, like I say, if you do have any questions, I'll work with anybody as far as costing, what the options are. And then also, the more I know about what you're talking about on your mission, your scenario, your telecom parameters, the more I can help you align to what the DSN can do for you. All right, got there on time, a little bit over. Questions, I guess?
Well, but we'll allow a couple of minutes for questions.
Hey, Steve, Dennis Wingo, are we going to, in the rules, be required to use JPL methodology in determining range?
Pseudo-noise ranging?
Like what we did with ISCD3, or doing Doppler like what we did at Arecibo?
There's a procedure for determining range, and it's documented in a document. It's called the Navigation Artifacts for Authenticating Claimed Communication Ranges and Successful Lunar Orbit. That's on the website. There's a talk about that by Dr. Ryan Park that's a little bit later this morning. We'll go into details. You can either use the DSN services to provide those navigation artifacts,
Can you just give us a first order cost, $1,000 a minute, $10,000 a minute?
Okay. The aperture fee, I was running short of time, so I forgot to mention it. The aperture fee for a 34-meter standard is $1,057 per hour. Each contact includes a 1 hour setup time on top of that 1 hour track, or whatever you decide. And then the more contacts per week, that rate goes up to penalize customers from hogging the network, basically, because it takes a lot more overhead, additional tariff and setup time. So it's a lot cheaper to do less contacts per week hourly than it is several contacts per week. In addition, the 70 meter, I had a question earlier, what about 70 meter? 70 meter is 4 times that, the 1,057 an hour. And then I'll work with the customers on the aperture fee. So it really depends on the number of contacts and how many hours, and whether it's a 14-day mission, 60-day, 90-day mission, or a year mission.
You know, on page 7 there, you showed the table of frequencies that you support with which assets. I really have seen in several locations the 70 meter is going to be refurbished for 32 gigahertz. By 2018, the question is, will the 70 meter asset at all 3 sites be available at the A-band of 32 gigahertz?
At the 32 gigahertz, I don't know offhand. I'd have to go
I
check.
think it's something that should be clarified, because if somebody's depending on that, it's a game changer.
You got my card right there. Can you send a question to me and I'll follow up on that?
Unfortunately, we're out of time, and Steve will be available for the remainder of the morning.